So, starting on number 1 of our Unit 2A study guide, we have what is the formula for the nth term of the given sequence. And right here, we can tell it's geometric from all the choices. All of these are telling us that we're multiplying, and if we tried to add, we'd find that we're not adding by the same amount, so it's not arithmetic. Remember, geometric, you multiply, and arithmetic, you add or subtract. Okay? So, to find out what we're dividing by, I can say the one in front divided by the one behind it, so 72 divided by 48. And then I can do the same thing with 108 divided by 72. Doing the math along with you all. So, type it in my calculator, 72 divided by 48. And then that gives me 1.5. And remember, you can press math, enter, enter. So math, enter, enter. Let's switch it to a fraction. So both of these are going to give me 3/2. So now my ratio is 3/2. And there's two ways I could write this. I can check and see. There's a bunch of this 32 action, but first, my first term here, term one is 48. So for this to be correct, it would have to be written as 48 to the 3/2 to the n minus 1, right? Because it's my first term, and my first term is here. So it's not the, so I know I have to write it for my zero term. So now I have to try my zero term. So let's write out what we have. So an equals 48 parentheses 3/2 to the n minus 1. That's writing it out as I normally would, but to write it for just term n, there's two ways you can do it. You can use the exponent rules to break it apart. So n 3/2 to the -1. Breaking this apart because when I multiply, I add here. So if I type that in my calculator, 3/2 to the -1 times 48. It's going to give me my starting term. If I multiply these two together, that gives me my zero term is going to be 32 to the 3/2 n. Okay. And if you're not a fan of that way, I totally understand. Let me erase here. I'll write it in blue. Another way you can do is plug in for the zero term and find it. So a0 equals 48 to the 3/2 0 minus 1. Type that in my calculator, and that'll give me 32. And then rewrite it as an equals 32 to the 3/2 n. And remember, it's just n because it's minus 0, because this is my zero term. In a geometric sequence, the first term is a1. I have a1 equals 7, and a3 is 28, and it wants to know the ratio of the geometric sequence. So remember, the generic formula here is an equals my starting term, and then my ratio to the n minus my starting term number. So I end at a3, because a3 comes after a1. I started at a1, and I can use it to fill in. So I end up at a3. This is kind of where I end at. So I end at a3, and I started at a1, and then I'm going to have r to the n. My n here is 3. So 3 minus my starting term number is 1, right? So I started at 1, so 3 minus 1, and then I just plug in and solve. So a3 is 28. My a1 is 7, and then I'm going to have r squared. 5 by 7. Then to get r by itself, I can take the square root and get that my common ratio is 2. Sorry. So Now we're doing something similar, except we have an arithmetic sequence in number 3. It gives us A1 and A10. So writing out the formula again for arithmetic is going to be very similar, but it's just changing it for the arithmetic, because arithmetic you add, double A. Arithmetic is add, so it's plus my difference to the multiplied by n minus my starting term number. Okay, so in this case I end at A10. It's going to be A10 equals A1. That's where I started at. Plus my difference. Obviously I don't know my difference here. That's what I'm using this to find. And then I ended at 10 minus 1. So if I plug in what I know, I've got 55 equals 19 plus 9D. Just generic algebra now. So my difference is 4. So to rewrite this, to write a general rule, it just wants the AN form, so it probably just wants the n minus 1, but we'll do both. So we could write this as AN equals my term 1. Let's write it for term 1. Term 1 is 19. So 19 plus, just plug in my difference that I just found, 4 to the 4 times n minus 1. Sorry, used to do in geometric a lot. And if I wanted to rewrite this as just n instead of n minus 1, I could distribute. And then just combine like terms. Okay, and remember that this is the form that we usually write in function notation. Function notation is usually written for the 0 term. So function notation usually written term. This is a key skill, for both arithmetic and geometric, being able to switch back and forth between n minus 1 and n. Okay. So moving up to number 4, just brought the nth term of the geometric sequence. Exactly like I said on number 3, you're going to have to do it for both. Now we're working with geometric. So to get my ratio, the nice thing is I can just divide these. So 4/7 divided by 3/7, because this is second divided by second divided by first, the one in front divided by the one before it, however you want to think about it. So just type in my calculator, 4/7 divided by 3/7. And that gives me 4/3. That's a weird fraction, so I would check it again just to make sure. It's okay to get a weird fraction for your ratio, but let's write it again. So 16/21 divided by 4/7, just to make sure it still checks out. Yep, 4/3 for that one. And then you could take these two again if you wanted to make sure, but here that's enough evidence to say that that is 4/3. Especially because it tells me it is a geometric sequence. If it didn't tell me which one it was, I'd probably check it a third time just to make sure, but that gives me my ratio is that. So I already know that my term 1 is there, so I can write it as AN equals my term 1, 3/7, 4/3 to the n minus 1. And if it wants it written in function notation, once again, you can do either of the two ways. You can do the exponent rules way, which is what I would recommend getting used to, or you can plug in the zero term. Okay, both are going to arrive at the same answer. So breaking this apart with exponent rules, if I want to write it in function notation, say, let's go ahead and get used to that. Function notation is 3/7, 4/3 in, 4/3 to the -1. I'm just breaking apart this with exponent rules. When I have multiplication, I can, when I have addition or subtraction, I can break it into multiplication and then multiply the highlighted terms together in my calculator. So 3/7 times 4/3 to the -1. And that gives me, oh, forgot to switch back to my pen. That gives me my function f of n equals 9/28, and then 4/3 to the n. And to show you for the zero term, you can do the same thing. I could find my zero term by plugging in f of 0 equals, because I'm using these interchangeably. I can plug in my 0 into my equation to find my zero term. Type in every bit of this into my calculator. So 3/7, parenthesis, 4/3 to the 0 minus 1 power, and that'll give me 9/28, and then just rewrite it. The f of n equals 9/28 to the 4/3 n. On 5, we have James has a James got an interest-free loan from his dad to buy a new gaming PC. The payments are shown below. There's two parts, A and B. Write the explicit formula and function notation for the scenario given. Notice it doesn't say if it's arithmetic or geometric. So you're going to have to find if it's adding or subtracting by the same amount. And then how many months will it take to pay off the loan? So let's do it in parts. So we have to look here. Am I dividing or am I multiplying? What's going on? Am I adding, subtracting? So I'm going to always try the easier one. I think addition and subtraction are easier ones. So I'm going to try to do 2710 minus 2800. And that will give me -90. And then try the ones beside it. And also do this and this. So 2620 minus 2710 equals -90. So that tells me it's arithmetic because I have a common difference. I'm adding -90 or subtracting by 90 every single time. So to be able to write the explicit formula in this situation, I know that it's arithmetic. I'm just going to start with A of n equals my starting term number. And notice here, I start after the first payment. So this is talking about term 1, not term 0. Term 1, not term 0. Because this is after I've made a payment already. This is after I've made a payment already. Okay? So because this is term 1, I'm going to write 2800 minus 90, because I'm subtracting 90 every time. Then I've got n minus 1. And notice, this is after, like this first number that I'm given here, that I'll highlight, like this whole first term is after I've made a single payment. So if it wanted me to write it in term 0, I would have to add 90 or distribute out. Let's say it wants it in function notation, just for n, I would just write it as 2800 minus 90 plus 90. And then I have -90 n plus 2890, and this is my, like, for my zero term. So my zero term, before he made any payments, the gaming PC cost him, like, or at least the loan that he got for that gaming PC was 2890, and I just used distribution to rewrite it. So that's for part A. And then part B wants to know, when is the loan going to be paid off? So, didn't mean to do that. So, as far as the loan being paid off, it's going to be when my balance is 0. So loan is paid off when balance is 0. So I can go down here and plug in 0 for what my function is outputting, because in here my f of n is talking about my loan balance. So 0 equals negative 90 n, and I'm going to use the function notation just because it's easier. 2890, and then just solve. So minus 2890 minus 2890 negative 2890. Do the math in the calculator and get 32.11 equals n. And remember here, it says how many months will it take to pay off. So we're assuming here that each payment is 1 month, like you make a payment on each single month. So how many months will it take to pay off the loan? Well, right here, this is saying 32.11 months or payments. Okay. So really, it's going to take me 33 months to pay it off, because at the end of 32 months, I'm not going to have it paid off yet. There's still going to be a little bit of a balance. That's where this highlighted 0.11 comes from. So I have to round up to the next month for it to be completely paid off. And then I have farmer Eddie stocking his pond with catfish. He starts by releasing 10 starts is an important word. Releasing 10 catfish into the pond. He buys a special kind of food that causes the amount of catfish to double every month. That's important. So write the formula in that can be used to find the number of catfish after T hours. So this is kind of like part A, and this is kind of like part B. I'll call them to make it easier to see. Write the formula in that can be used to find the number of catfish after T hours. So I have to figure out in the first place, is this talking about an arithmetic, geometric, exponential? Like what am I talking about here? So I would think of this, because I'm doubling, that means multiply by 2. That doubling portion tells me I'm multiplying, and multiplying goes with geometric. So I'm just going to start by writing AN, like for part A, I'm going to write out the formula. Okay, for geometric. So now I have to figure out, well, I know my ratio is going to be 2 because I'm doubling every month. I'm multiplying by 2. That's simple enough. And then, what is this 10 talking about? Well, it doubles every month, and when he releases the 10 catfish in here, like he starts by releasing it, no months have passed. Because remember, in these kind of problems, time usually starts at 0. I stress that a lot during the lessons, because in these scenarios, we're talking about like every time we go up, it's after a month has passed. But in this case, no months have passed, so I'm working with term 0. This is, the 10 is term 0. Okay? And it wants it written as N of T, and this is a multiple choice question, so you don't have to stress, but it's going to be written in N of T form. So the number of fish after a certain amount of time. It's basically the same thing as F of N, just written for different letters. So N of T equals, my starting term is 10, so I started with 10 times 2 to the N. Or in this case, instead of N, it wants me to use T, so it'd be 10 times 2 to the T. Okay? And then for part B, how many catfish will there be in 11 months? Well, it just wants N of 11. So 10, 2 to the 11th. Just type it in your calculator. These catfish are going to outgrow this pond pretty quick, it seems like. 2 to the 11th. Yep. So there will be 20,480 catfish after 11 months. So write the equation for the exponential function from the values given in the table. Remember, you always, with exponential functions, you basically start with that zero term. It doesn't want -1, it doesn't want anything like that. And the other thing that might trip you up here is, notice we're starting at -3, and the term that we actually want to use is here at the end. So we want to start at that zero term always, no matter where it's at, because this is telling me what term I'm at. So if I'm going to write it out, and remember, it's usually in this f of x equals a times b to the x, really similar to writing a geometric equation in function notation. So I know my zero term where I start here is at 9, and then I got to find what I'm going up by every time. Well, to do that, I just divide these. So 144 divided by 576. Do it in my calculator. That gives me 0.25, and then math enter again. 1/4. Okay, so 1/4, and then to be sure you can check again. 9 divided by 36 gives me 1/4. So boom, that quick. Basically like writing a geometric one for zero term. And the last one for this video is going to be number 8. Write the function for the given sequence and name how many terms. So you need to write the function and name the terms. So 2 parts. So I have to see if this is arithmetic or geometric, but you can kind of see right off the bat it's switching back and forth signs, so it's probably geometric because I'm multiplying by something. I got -12 divided by 3. It's -4. 48 divided by -12. It's -4 as well. So I know my ratio is -4. Okay. Ratio is -4. And then this is term 1. So I can write it out as a n equals 3 parentheses -4 to the n minus 1. And if it wanted it in function notation, or it gives you to you in function notation, you either use the zero term method or the exponent method. I'm assuming most people are going to use the zero term method. So to do this, I'm just going to plug 0 into here to get the zero term. Plug that in my calculator. 3 parentheses -4 to the 0 minus 1. Math enter because it gave me a fraction. I mean a decimal. I don't like decimals. -3/4. So written for the zero term, or written in function notation, it would be -3/4 to the -4. I mean, -4 to the power of n, because once again this is my zero term. And then what I would do when it says name how many terms there are in the sequence, well, I know from like all of this, my ratio tells me to multiply by -4 every time. I'm just going to write out the whole list and count them. So -3, 12, 48, and then just time. So I'm going to put 48 in here times -4, -192, 768, 3072. 12288. -4 9. Oh, already went too far. Boom. So I already finished the list because I know I'm finished when I get to this last part of the bracket here. So if I count these in blue, I've got 1, 2, 3, 4, 5, 6, 7 terms.